Hello everyone, and welcome to another math video. I'm Professor Diwa. In this video, we'll be going over systems of linear equations in three variables. Our objectives are to solve a system of three linear equations in three variables. Alright, so let's get started. First, we're going to talk about the graphical representation of a linear equation in three variables. So a linear equation in three variables represents the graph of a mathematical plane. A mathematical plane is essentially just a two-dimensional surface graphed in a three-dimensional space. If you take a look at the diagrams we have here under identifying solutions, we have a bunch of two-dimensional surfaces, intersecting, not intersecting. In any case, each one of those two-dimensional surfaces represents a linear equation in three variables. If we take a look at diagram A, you can see that we have three planes all intersecting at a single point. That single point represents the solution to that system. We would classify the system as consistent because we have at least one solution. When we have a single solution to a system of three equations in three variables, it's represented by an ordered triple. It's very similar to an ordered pair, but an ordered triple has three numbers instead of two. We have an x-coordinate, a y-coordinate, and a z-coordinate, where an ordered pair only has an x and y coordinate. In the first diagram for part B, we have three planes intersecting on a single line. That single line represents an infinite number of solutions. We can also have another situation occur where we have an infinite number of solutions. In the second diagram for part B, we have three planes overlapping one another. All three planes intersect each other at every single point. We would classify both of these diagrams as consistent. Moving on to part C, in the first diagram we have three planes that intersect each other, but we don't have all three planes intersecting at one time. At most, we have two planes intersecting at one time. This means that this system has no solution. In the second diagram for part C, we have three parallel planes. They don't intersect, so there's no solution. Since both systems have no solution, we classify them as inconsistent systems. In example number 1, determine if the ordered triple 1, 3, -4 is a solution to the system. The first equation is x plus y plus z equals 0. The second equation, 2x minus y plus 3z equals 17. The third equation, -3x plus 2y minus z equals -21. To determine if this ordered triple is a solution to the system, all we need to do is plug in the values for x, y, and z into all three of the equations. For the first equation, we have x plus y plus z equals 0. We plug in 1 in for x, 3 for y, and -4 for z. We get 1 plus 3 plus -4 equals 0. Simplifying the equation, we get 4 minus 4 equals 0, which simplifies to 0 equals 0. Because this is true, we move on to the second equation, 2x minus y plus 3z equals 17, and we plug in the same values for x, y, and z. We get 2 times 1 minus 3 plus 3 times -4 equals 17. Simplifying this equation, we get 2 minus 3 minus 12 equals 17. Simplifying this equation further, we get -1 minus 12 equals 17, and the final result is -13 equals 17, which is false. -13 does not equal 17, so this means that the ordered triple 1, 3, -4 is not a solution to the system of equations. Note that the only time that you would need to check all three equations is if the first two equations ended up being true. Just so you guys could see the results when we plug in our ordered triple into the third equation, I'm going to work it out. We have -3x plus 2y minus z equals -21. Plugging in our ordered triple, we get -3 times 1 plus 2 times 3 minus -4 equals -21. Simplifying this equation, we get -3 plus 6 plus 4 equals -21. Simplifying this equation further, we get 3 plus 4 equals negative 21, and the final result is 7 equals negative 21. This is false. 7 does not equal negative 21. So if this was the first equation that we worked out, we would automatically stop here and say that the order triple is not a solution. Next, we're going to go over solving a system of 3 linear equations by the elimination method. The first step is to write each equation in standard form. Capital AX plus capital BY plus capital CZ equals capital D. The second step, choose a pair of equations and use them to eliminate a variable. The third step, choose any pair of equations and eliminate the same variable as in step 2. Step 4, 2 equations and 2 variables should be attained from step 2 and step 3. Use the substitution or elimination method to solve this system for both variables. Step 5, to solve for the third variable, substitute the values of the variables found in step 4 into any of the original equations containing the third variable. Step 6, check the ordered triple solution in all 3 original equations. Alright, so let's go ahead and see how we apply this to an example. For example number 2, solve the system of equations. For the first equation, we have x minus y plus 2z equals 6. The second equation is 2x plus y minus 2z equals negative 3. The third equation, negative x minus 2y plus 3z equals 7. You can see here that all 3 equations are written in standard form. What we need to do next is pick 2 equations and choose to eliminate a variable. For this example, I'm going to choose equation number 1 and equation number 3, and I'm going to choose to eliminate the x variable because they're already opposites. So taking equation 1 and 3 and adding them together, we get x minus x cancels out, minus y and minus 2y is negative 3y, 2z plus 3z is 5z, and 6 plus 7 is 13. So the result is negative 3y plus 5z equals 13. Now this new equation that we have, I'm going to call it equation number 4. Next, we pick 2 more equations. One of the equations has to be an equation that we haven't used yet. So I'm going to use equation number 2 and equation number 3. And we're going to eliminate the same variable x. You can see here in equation number 3, we have negative x, and equation number 2, we have 2x. What we need to do here is change the negative x in equation 3 to be negative 2x. To do this, we just multiply equation number 3 by 2. We get negative 2x minus 4y plus 6z equals 14. Now we could add this to equation 2 so that we could eliminate the x variable. We get 2x minus 2x cancels out, y minus 4y is negative 3y, minus 2z plus 6z is 4z, minus 3 plus 14 is 11, so the result is negative 3y plus 4z equals 11. I'm going to call this new equation equation number 5. So what we do now is we're going to take equation number 4 and equation number 5 and solve it by using elimination. You could see here that the y variables would be the easiest to eliminate because they're both negative 3y. We just need to change one of them to be positive. So I'm going to take equation number 5 and multiply it by a negative 1. We get positive 3y minus 4z equals negative 11. Now we could go ahead and do the elimination. So we have minus 3y plus 3y cancels out, plus 5z minus 4z is z, 13 minus 11 is 2, the result is z equals 2. Next we could substitute our value for z into equation 4 or equation 5. I'm going to substitute it into equation 4. So I have negative 3y plus 5 times 2 equals 13. This simplifies to negative 3y plus 10 equals 13. Next, we go ahead and solve for y by eliminating the 10. So we subtract 10 from both sides of the equation. Simplifying the left-hand side, 10 minus 10 cancels out, and we bring down the minus 3y. On the right-hand side, 13 minus 10 is 3. The result is negative 3y equals 3. From here, we get rid of the negative 3 by dividing both sides of the equation by negative 3. We get negative 3y divided by negative 3 equals 3 divided by negative 3. Simplifying the left-hand side, negative 3y divided by negative 3 is y. 3 divided by negative 3 is negative 1. The result is y equals negative 1. The next step is substituting our value for z and our value for y into any one of the three original equations. I'm going to choose equation 1. We substitute in negative 1 for y and 2 for z. We get x minus negative 1 plus 2 times 2 equals 6. Simplifying the equation, we get x plus 1 plus 4 equals 6. Simplifying further, we get x plus 5 equals 6. Solving for x, we could get rid of the positive 5 by subtracting 5 from both sides of the equation. Simplifying the left-hand side, plus 5 minus 5 cancels out. We bring down the x. On the right-hand side, 6 minus 5 is 1. The result is x equals 1. The last step here is writing your final answer as an ordered triple. So I have parentheses, 1 comma negative 1 comma 2, close parentheses. Next, we have a practice problem for you to solve. Solve the system of equations. The first equation is x minus 2y plus 2z equals 3. The second equation, negative x plus y plus 3z equals 7. The third equation is x plus y minus 3z equals negative 7. So go ahead and pause the video, take your time working out this problem, and then check back with the video to see the solutions. Alright, so let's get started. First, I'm going to pick equation 1 and equation 2 and eliminate x. Combining those two equations together, we have x minus x cancels out, minus 2y plus y is negative y, 2z plus 3z is 5z, 3 plus 7 is 10. So the result is negative y plus 5z equals 10. This will be equation number 4. Next, we pick two more equations and eliminate the same variable x. I'm going to use equation number 2 and equation number 3. When we do the elimination, we get minus x plus x cancels out, y plus y is 2y, 3z minus 3z cancels out, 7 minus 7 is 0. The result is 2y equals 0. From here, we could solve for y by dividing both sides by 2. We get 2y divided by 2 equals 0 divided by 2. Simplifying the left-hand side, 2y divided by 2 is y. On the right-hand side, 0 divided by 2 is 0. The result is y equals 0. From here, I could take my value for y and substitute it into equation number 4. We get 0 plus 5z equals 10. From here, we could get rid of the 5 by dividing both sides by 5. We get 5z divided by 5 equals 10 divided by 5. Simplifying the left-hand side, 5z divided by 5 is z. On the right-hand side, 10 divided by 5 is 2. So we have z equals 2. From here, we could substitute in our value for z and y into the first equation. We get x minus 2 times 0 plus 2 times 2 equals 3. Simplifying this equation, we get x minus 0 plus 4 equals 3. Simplifying further, we get x plus 4 equals 3. From here, we could solve for x by getting rid of the 4. We just subtract 4 from both sides of the equation. Simplifying the left-hand side, 4 minus 4 cancels out, and we bring down the x. On the right-hand side, 3 minus 4 is negative 1. The result is x equals negative 1. Our solution to the system is parentheses, negative 1, comma 0, comma 2, close parentheses. Next, we have example number 3. Solve the system of equations. For part A, the first equation is x plus y plus z equals 4. The second equation is negative x plus y plus z equals 2. The third equation, y plus z equals 1. Notice here that equation number 3 only has 2 variables. This is going to make this problem a lot easier to solve because we won't need to do so much elimination. We just need to get one more equation with the same 2 variables. So what I'm going to do here is pick equation number 1 and equation number 2 and eliminate the x variable so that I'm left with an equation with a y and z variable in it. Doing the elimination, we get x minus x cancels out, y plus y is 2y, z plus z is 2z, 4 plus 2 is 6. So the result is 2y plus 2z equals 6. This is going to be equation number 4. Next, we need to take equation number 3 and equation number 4 and eliminate the y variable. To eliminate the y variable, we need to change the y from equation number 3 to negative 2y. To do this, we just multiply equation number 3 by negative 2. After doing the multiplication, we get negative 2y minus 2z equals negative 2. Now we could combine this equation with equation number 4 and do the elimination. We have negative 2y plus 2y is 0, minus 2z plus 2z is 0, minus 2 plus 6 is 4. The result is 0 equals 4, which is false. 0 does not equal 4. This means that this system has no solution. For my final answer, I drew a circle with a diagonal line going through it to represent that this system has no solution. Moving on to part B, the first equation is x plus y plus z equals 2. The second equation, x minus y plus z equals 4. The third equation, 3x minus y plus 3z equals 10. To solve this system, I'm going to start off by taking equation number 1 and equation number 2 and eliminating the y variable. The reason why I'm choosing the y variable is because they are already opposites. Doing the elimination, we get x plus x is 2x, y minus y cancels out, z plus z is 2z, 2 plus 4 is 6. The result is 2x plus 2z equals 6. This is going to be equation number 4. Next, I'm going to take equation number 1 and equation number 3 and eliminate the same variable y. Again, the y variables are already opposites. Doing the elimination, we get x plus 3x is 4x, y minus y cancels out, z plus 3z is 4z, 2 plus 10 is 12. The result is 4x plus 4z equals 12. This is equation number 5. Next, we're going to take equation number 4 and equation number 5 and eliminate the x variable. For equation number 5, we have 4x, and equation number 4, we have 2x. To eliminate the x variable, we need to change the 2x in equation number 4 to negative 4x. So we just multiply equation number 4 by negative 2. Doing the multiplication, we get negative 4x minus 4z equals negative 12. Now we could add this equation to equation number 5 and do the elimination. We get negative 4x plus 4x is 0, negative 4z plus 4z is 0, negative 12 plus 12 is 0. The result is 0 equals 0, which is true. This means we have an infinite number of solutions for this system. We write out our final answer using set notation. So I have a set of curly brackets. Inside the curly brackets, I have parentheses, x comma y comma z, close parentheses, a vertical line, x plus y plus z equals 2. So what this means is our solution is the set of ordered triples, x, y, and z, such that it satisfies the equation x plus y plus z equals 2. Now we could actually write our final answer in 3 different ways. So this is the first way. The other 2 ways we could write out our answer are exactly the same, except we use the other 2 equations. So you can see here, I wrote out the same exact notation, except I have the second equation on the inside. I have x minus y plus z equals 4. For the third way, again, I have the same exact notation written out, except I have the third equation written on the inside. I have 3x minus y plus 3z equals 10. Next, we have a practice problem. Solve the system of equations. For part A, we have the system of equations x minus y plus 2z equals 2. For the second equation, we have negative x plus 2y minus z equals 0. For the third equation, we have x plus 3z equals 4. For part B, we have the system of equations x plus y plus z equals 1. For the second equation, we have negative x plus y minus z equals 7. For the third equation, we have x plus 3y plus z equals 8. So go ahead and pause the video, take your time working out these problems, and when you finish, check back with the video to see the solutions. Alright, so let's get started. The way I went about solving this problem was I took equation number 2 and equation number 1, and I eliminated the y variable. To eliminate the y variable, I had to multiply equation number 1 by 2. When we do the multiplication, we get 2x minus 2y plus 4z equals 4. Now we could combine it with equation number 2 and eliminate the y variable. We get 2x minus x is x, minus 2y plus 2y cancels out, 4z minus z is 3z, 4 plus 0 is 4. The result is x plus 3z equals 4. This is going to be equation number 4. Next, we could combine equation number 4 and equation number 3 and eliminate the x variable. To eliminate the x variable, I chose to multiply equation number 4 by negative 1. We get negative x minus 3z equals negative 4. Now we could combine it with equation number 3. Doing the elimination, we get x minus x is 0, 3z minus 3z is 0, and then 4 minus 4 is 0. The result is 0 equals 0. This is a true equation, so we could write out our answer in 3 different ways. The first way I wrote my answer is using a set of curly brackets, and on the inside of the curly brackets, I wrote parentheses, x comma y comma z, close parentheses, a vertical line, and then I wrote out the first equation, which is x minus y plus 2z equals 2. The second way we could write our answer is exactly the same, except we use the second equation, and then the third way we write our answer, again, is exactly the same, except we use the third equation. Alright, so let's move on to part B. For part B, I started off by combining equation 1 and equation 2 and eliminating the y variable. To eliminate the y variable, I had to multiply equation 2 by negative 1. We get x minus y plus z equals negative 7. Now we could combine this equation with equation 1. So doing the elimination, we get x plus x is 2x, y minus y cancels out, z plus z is 2z, 1 minus 7 is negative 6. The result is 2x plus 2z equals negative 6. This will be my equation number 4. Next, I took equation number 2 and equation number 3 and eliminated the same variable y. To eliminate the y variable, I had to take equation number 2 and multiply it by negative 3. We get 3x minus 3y plus 3z equals negative 21. Now we could combine it with equation 3 and do the elimination. 3x plus x is 4x, minus 3y plus 3y cancels out, 3z plus z is 4z, negative 21 plus 8 is negative 13. The result is 4x plus 4z equals negative 13. This is my equation number 5. Next, we could combine equation number 5 and equation number 4 and eliminate the x variable. To eliminate the x variable, I just multiplied equation number 4 by negative 2. We get negative 4x minus 4z equals 12. Now we could combine this equation with equation number 5 and do the elimination. We get negative 4x plus 4x is 0, negative 4z plus 4z is 0, 12 minus 13 is negative 1. The result is 0 equals negative 1, which is false. 0 is not equal to negative 1, so this system has no solution. To represent that this system has no solution, I wrote my final answer using a circle with a diagonal line going through it. Alright, so this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.